Hi everyone. In a recent video I showed how I built the Chromium Embedded Framework sample project on my Windows 10 machine using native tools like Visual Studio. But in this video what I'm going to try to do is to capture how I built the same sample project on my Raspberry Pi 4 Model B with 4 gigabytes of RAM and a 128 gig micro SD card. The machine is running Raspbian 10 Buster, and it's the machine that I've normally used for these videos. So it has a lot of the tools built, that a lot of the dependencies are already available. It's already installed. But just going to the to this web URL, this is on bitbucket.org under Chromium Embedded. This is the CEF project. So Chromium Embedded Framework is basically a framework that is open source and is cross-platform. So with that, the application can actually use a browser as its user interface. And since it's cross-platform, I wanted to see if I could make the sample project run on my Raspberry Pi, as I showed in the previous video. Was running on Windows 10. Chromium Embedded Framework does support a number of different platforms, and they have different build steps for it. This, by the way, this CEF project is the repository for the sample project. So this is the Chromium Embedded Framework sample project. The repository for CEF itself is under the same bitbucket.org website, but the repo name is CEF. And so just want to make sure that I'm not trying to build CEF itself. CEF is available in binary distributions as well, and there are binaries that are built already, pre-built already for Linux, for ARM. So here is the Chromium Embedded Framework Automated Builds URL. As you can see, it supports, they have builds that are automated for 32-bit Linux, that's x86. This is the Linux 64-bit, which is x86-64 architecture. This is ARM, and this is actually the 32-bit ARM. So this is the one that I'll be using for Raspberry Pi. Since the Raspbian OS is a 32-bit OS, I'm going to use the 32-bit binaries from CEF. But they have 64-bit binaries also pre-built, as well as for 64-bit Mac OS, ARM 64, and also 64-bit Intel x86-64 architecture, Intel 32-bit, and Windows 32-bit, Windows 64-bit, and Windows on ARM 64. So as you can see, CEF is quite widely supported, and I'm not going to build the binaries for CEF itself, but the project, the sample project itself, supports a number of targets. For example, it has support for Linux, but this is basically Linux on x86 architecture. As you can see, the architecture is not specified in the CMake. It also runs the sample project can also support, can also be compiled and built on Intel x86 64-bit on Mac OS, as well as ARM 64. So these are different CMake commands that you can give, as well as it can be built on Windows 32-bit, on the x86 platform, and on Windows 64-bit, which is the Intel x86 64 architecture. So these are the supported platforms for the sample project, but I don't see in this list Raspbian or Raspberry Pi or Linux on ARM 64. So I had to do a little bit of changes to the CMake files to get it to build, since CEF itself is already pre-built for ARM, Linux ARM, and Linux ARM 64. I didn't see any reason why I would not be able to succeed in building it, maybe with a little bit of modifications, building the sample project, I mean. So if you go to the repo for the sample project, basically it's a fairly simple repo, a small repo. There's the CMake files, the example files, source files, the tools, and here's the CMake lists. They're showing a couple of pages here. There's a tutorial. This tutorial describes one of the simpler projects that are in the sample project, simplest apps. And then there's another wiki page called for general usage, which goes a little bit more in depth into the different sample applications that they provide. So I'm hoping to be able to run CF client and CF simple on my Raspberry Pi after this video. So as you can see on my Raspberry Pi, I'm running it with Linux kernel 5.483, and this is an ARM v7L, so it's a 32-bit kernel, and it's running the standard Raspbian Buster 10, Raspberry OS, Raspberry Pi OS, and then I did sudo apt update. I did sudo apt upgrade, so everything is up to date. I have because this is my normal build machine, I'm not sure what packages you may run in if you try to duplicate these steps. But I did run across this one package that was missing, and it gave me an error. So I had to install this extra package. It's libgtk glex tmm x11 1.2-dev. So this caused an error. So that was a dependency that was missing from my Raspberry Pi. So I installed that. So as you can see, it is installed. My CMake version is 3.16. My Python version is 2.7.16. And as you can see, my GCC is version 8.3. I'll give the command to clone it. And this is a short repository, so it clones pretty quickly. So then go to CEF project. And if you look at the listing of this directory, it has what we saw in the repo. But what we need to do is to make a build directory and go into the build directory. So this is where we're going to issue the CMake command. But before we can actually run the CMake command, if I run it right now, it will not detect Linux for ARM, 32-bit ARM, because the CEF project, the sample project, doesn't support Raspbian or Linux or ARM, Linux running on ARM yet. So what I have to do is to come back up to the main repo root directory and edit the CMake.list file. So going into the to this, what we'll see is that for Linux in CMake, if the system name is Linux, it'll check and see if the size of a pointer, void pointer, is a 8 by 8, then it'll be treating it as a 64-bit system. Otherwise, it'll treat it as a 32-bit system, so Linux system. But that Linux 64 and Linux 32, they mean x86 Intel architecture, not ARM. So since I'm only interested in this video for to get this to compile for Raspbian, I'm going to add a few lines under here. So basically, I'm adding these 3 lines, and I'm saying if I provide this keyword project architecture on the command line for running when I'm running the CMake, and I say this is project architecture is Linux ARM, then set the CEF platform to be Linux ARM. So the CEF platform is an internal CEF CMake variable, and then project architecture Arch is something that I can provide on the command line. And it is used, for example, on the Mac OS build, so you can specify that project Arch. So basically what I'm doing is I'm going to make this change so that I've added these 3 lines. And somehow these control M's are showing up when I do a git diff, and that's probably because of the line ending settings somewhere here. It doesn't affect the build, so I'm not going to worry about that one. So with that, I can go back to the build directory. So what I'm going to do is I'm going to take this CMake file, CMake command, which is for building on Linux, and I'm going to add the project Arch variable to it. And the value that, as you can see on it was used, for example, on Xcode or for Mac OS, project Arch there is given as x86, but here for Linux it's not. But so I had to guess a little bit, and it seemed like it made sense, because if I go to the automated builds, you can see that the project, the CF platform Linux ARM is what is given here at the end of the pre-built binaries. This is Linux 64, this is Linux 32, this is Linux ARM for 32-bit ARM, this is Linux ARM 64, and so on. So this text here, macOS ARM 64 or Linux ARM 64 or Linux ARM, corresponds to the CEF platform and also corresponds to project Arch environment, the CMake variables. So seeing this, I figured I could modify this command here, because this is what I need to build it. So I'm back in the build directory, and here I'm going to paste the command from that page, but I'm going to add a definition -d project Arch equals Linux ARM. So that's all I'm adding after modifying the CMake lists, the text, to add this. So this is going to say, oh, okay, if the user specified project Arch on the CMake command line, set the CF platform to Linux ARM. If it was specified as Linux ARM, set the CF platform to Linux ARM. And then the rest should work. So that's all I'm doing. So I'm going to hit enter. And what it's going to do, CMake is going to go check, and as you can see here, it is now downloading the Linux ARM binary. Okay, so it looks like it's finishing the download. And then the next thing it's going to do once the download is complete, it just downloaded a big tarball and it's going to extract it. And that's going to take a little bit of time. So here it's finished with downloading, finished downloading this file, CEF binary, version 87.1.12, which is the latest build that was available on the website for the pre-built binaries for Linux ARM. As you can see here, it is for Linux ARM. So it's a tarball of that the CEF, it's version 87.1.12, and I guess it's got Chromium 87 is the version of the Chromium that's built in. Okay, so it's finished. But let me just go over the process that happens after the download is complete. So it extracted the CEF binary into this. So this is the home. This is a root home project, home of the project. So there is a third-party directory, third-party CEF binary. That's where it extracts it. And so when it extracts it, it puts it under the same place that it downloaded the tarball. So this is the path of the extracted folder where all the pre-built binaries are. And then CMake is able to detect that CEF root is at that location. There is a variable that I probably could have set, but I don't, and it's not required, but it could make it cleaner. So then it goes, CMake goes and starts detecting the build system environment, and it finds that I have Python 2.7.16 installed. And then just keep in mind, you do need the Python 2.7 version. Python 3, when I tried it on Windows 10, this step would fail. So with Python 2.7.16, the script that downloads CLang format from Google Storage is compatible with Python 2.7. So with 2.7.16, this is downloading CLang format, and it puts it in a new a place called tools build Linux 64 CLang format. For some reason, it's putting it on the Linux 64. I'm not sure why, but it doesn't seem to affect the outcome. So then what it says is it detected that the platform is Linux, the project architecture is Linux ARM, I'm building a release build, sandboxing is available, and then X11 libraries are used. Shows all the compiler flags. If it doesn't detect ARM, it'll start using some of the compiler flags that are for x86, and the compile stage will fail. But this is good because I don't see any of the compiler options for x86 architecture. So then what it says at the end is that it was able to put the build the build files in the build directory. So we're in the build directory. So let's see how it changed. So in the build directory now there is a third party, and again this third party directory is not the same as this one. This one is not under build. This one is directly under the root of the project. So that's where the binaries are extracted. The CEF binaries are extracted, but then when CMake configuration is done, whatever is required from those binaries, pre-built binaries, are brought into the third-party directory under the build directory. But the build directory is now ready to go, and I can do the make command here and let it start the make, and it'll start building. And as you can see, the compiling is taking place and there's no compiler errors, and that's a good sign, because if the right architecture was not detected, this would have failed. The first file that it tried to compile would basically result in a compiler error, and it will say that you're trying to build with the options that are compiler options like M32, MMX, and things like that that are basically not for that. They're for x86, not ARM. So it has so far at about 65%. It's compiled all the files that are necessary for building the sample CEF client, and it's now linking it. All right, after linking CEF client, it'll start to compile CEF simple. That's a fairly quick compile, and it'll do the linking. And a little bit before linking these two binaries, it had finished building a wrapper, the DLL wrapper. So, but these are the first two sample projects, and these are the ones that I want to be able to run on the Raspberry Pi. So CEF client seems like it succeeded. There is this line that you can see. This particular line is given here, and this has to do with setting the permissions for the sandbox. So it looks like it's getting closer to the end. It took a long time. I did give the make command without the -J4 option that was recommended on the wiki page for CEF project. I normally do that as I've from time to time I've seen that that's usually tested on some of the heavier systems like x86 and not on the Raspberry Pis. So I've become a little bit more cautious about it and just run the make without the -J4. But once I see that it builds, then I normally on subsequent builds I would try the make -J4 option. In the build directory now, again under release, there is this program called minimal, and I can execute that directly right now, and it will run the simple project. So as you can see, this is the minimal application that was built in the release. It's launching and it's presenting this web page. But the projects the binaries that I was looking for are built in the build directory under third-party CEF binary tests, and then there are CEF client, CEF simple, CEF test, gtest. So I'm going to run CEF simple. This should look and feel the same as the minimal application that, and I'm going to, since it's a release build, I have to say release, and then if I can run it. So third-party CEF, give the full path. I could also switch to that directory, but I can run it directly from here. And again, this will launch the same simple application. But as you can see, it's a live application. So, but the one that I want to really, that has a little bit more features is the CEF client. Release CEF client. So if I run that one, as you can see, it has a little bit more bells and whistles. First of all, it has this URL. but it has a menu, and this is the user interface of this application. And there are some things you can do, and this is the way the user can interact with the C++ program. For example, you can run the source of this page. You can get open a new window. As you can see, it opened a new window. You can let's see, plug in info. It can show this information. It can zoom in, so you can zoom it in, zoom it out, reset the zoom. It's got some tracing and printing, and some support for audio, and then some other tests, it says. So various other internal and external tests. I haven't run any of these, but I'll run the accelerated 2D canvas, see what happens. Okay, that looks good. That's all running inside this web browser. Moving the mouse, it's responding, and it's pretty responsive. So there's a bunch of other tests. Let's see the WebGL. Console messages written. Okay, so here's a WebGL test, and I can go back. But hopefully this was useful. I know I'll be able to refer to it to these videos down the line for when I forget some of these things I've done. I can always look back. That's the purpose of these videos, but I share it just so in case other people find it useful as well. Take care, and catch you in the next video. Take care.